Hi everyone, so today we're going to be working on more translations. So just as a reminder, the ones that we already did, f of x plus something inside, we did f of x minus something inside, this would be left, this would be right, and then we also had f of x plus something on the outside, this would be up, and then f of x minus something on the outside, this would be down. So I'm not going to re-go through those. Those are kind of ones we expect that you guys remember from the previous lesson. So definitely make sure you feel good about that. And we're just going to add some more on. So the first one we're going to talk about is when something is multiplied on the outside of the function. Okay, so something is multiplied in front. Okay, if a is greater than 1, and actually the absolute value of a, it's a vertical stretch. Okay. One note here in general, okay, if a is negative, okay, you flip over the x-axis, or all the y's are multiplied by -1, okay? If a is between 0 and 1, like 1/2 or -1/3, okay, technically it's a vertical shrink, so it will kind of be more of a shallow graph, depending on what the shape is. So it's still vertically affecting the y's, and in a general sense, right here, we see this written, really important, multiply the y values by a in order to change the graph. So it's going to be stretched or shrunk. Okay, if a is inside, now this is kind of a special situation. So for example, if I had like 1/3 x cubed or something like that, where there's a constant inside multiplying the x, okay, that's impacting the x values, okay, and you're going to multiply the x values by the inverse. Okay, so let's say, actually, I'll keep that example. Oops. So 1/3 x cubed. Okay, if that whole thing was cubed, then the inside we multiply the x's by 3, because the opposite of 1/3, the reciprocal. So it's not the opposite reciprocal, just the reciprocal. So flip that fraction. Okay, and so again, that would be a is between 0 and 1. If a is greater than 1, same thing. So like if it was, I don't know, 2x squared, okay, that's one option you could do, and you would multiply the x's by 1/2. Okay, the opposite. That one's not very typical, and to be honest with you guys, I just wanted to clarify, we're not going to be graphing these in a sense. We're only going to be graphing them with the greatest integer, or that step function, but you do need to know what it does to a set of points. So I could give you a set of points like this, and you need to know what this does. All right, so we're not going to be graphing it this year right now, but you're definitely should still know what happens to the x values. Again, if something is multiplied inside, we multiply the x's by the reciprocal. Okay, so let's take a look at a couple examples. Example 0 here has 3 points. Find the new points if we transform this function. Okay, so you need to decide what happens to these points if I have a -1/2 out front. Well, that means I multiply the y's times exactly what's out front, right? So whatever's out front, we multiply the y's, and we get -2, and then 4 times -1/2 would be -2. 3, 6 times -1/2 would be -3. And 5, 9 times -1/2 would be -9/2. Okay. How about if I have a 1/3 inside? Okay, 1/3 inside is going to tell us to do x's times 3. X's times 3. So that being said, okay, we want to take all the x's. Again, we're multiplying by the reciprocal of 1/3. So instead of -2, we have -2 times 3 is -6, 4. Again, just use the original y values. Then next pair would be 3 times 3 is 9, 6. And then 5 times 3 is 15, 9. All right, we're going to save number 3 to work on in class. Now we're going to dive into actually graphing these. So as I mentioned, the ones we're going to be graphing are these two, okay, for the most part, except for step functions. We'll try this out because it's kind of an interesting example. So take a look at number 1, okay? For absolute values, whatever number's out here, the nice part is, if you guys remember, if you look at your parent function for an absolute value, which of course you remember, those points right there, okay, if it's changed to 2 or 2/3 or 5/2 or whatever it may be, it actually just tells you the slope of this line, Okay, so like your new points here for 2, think about it this way. Well, your y value is 0, 0 times 2. This is multiplying the y's times 2, right? So take all your y values, multiply it by 2. So this y value is 1. 1 times 2 is 2. This y value is 2. 2 times 2 is 4. Okay. Negative 1 times 2 is 2. Negative, or 2. Sorry, I meant to say 1 times 2 is 2. 2 times 2 is 4. So again, here's what I want you guys to see. What's the slope of these lines right here? Up 2 over 1, up 2 over 1. It would keep going that way. So this actually just tells you, it's just in an absolute value specifically, kind of the slopes, and you get positive or negative 2 as your two slopes for that new graph. Okay, so if I had a 3 out there, then my slopes would be 3 and negative 3. Okay, again, what's happening here, if you want to look at this from a table perspective, is here is my original points. I took all of these guys and multiplied by 2. So my new table was keep the x values, and I got 4, 2, 0, 2, 4. Okay, and that's what I just graphed. Now, as you guys know, the last step is I'm going to erase the lines here because I'm actually not done. In red, I'm going to do this transformation. Left 3, down 5. Okay, so left 3, down 5 would be right here. Okay, and then again, it's that slope of 2. So you can pretty much just find that starting point, left 3, down 5. And then you know you have slope of 2 and negative 2 as your two pieces. Or you can simply shift the green graph down, down through left 3, down 5, and we are done. Okay, so those are the two pieces. What you should do first is that vertical stretch, then deal with the left and right shift. So get it to be the right shape, then shift it horizontally or vertically. Okay, let's take a look at example 2. All right, example 2 is a quadratic. Now, you should have been able to graph something like this in Algebra 1. Okay, the reason for this is for specifically a quadratic, okay, for an x squared graph, we have this 1a, 3a, 5a pattern. Okay, I've mentioned this to you guys. Some of you are like, yeah, I've heard of it. Okay, here's the official lesson on it. So this is called an a value, the number out front. So a is negative 3. So you're going to plug in negative 3 to each of these. 1 times negative 3 is negative 3. 3 times negative 3 is negative 9. 15 times negative 3 is negative 15. Okay, these are going to be your movements. So let me show you what I mean here. You're going to start at 0, 0. Instead of going up 1 over 1, you're going to go up, in this case, we're going to go down. Because it's negative, we know we're flipped over the axis. We're going down 3. So we're going to go down 3 over 1, and then down 9 over 1. And of course, that does not fit on the graph, but there's my sketch of it. So it's going to be vertically stretched, okay? And this might end up fitting on the graph depending on where we start at. But in a general sense, that's what it looks like. So it's going to be this very narrow looking quadratic because it's vertically stretched by 3, okay, and facing down. Again, if you don't like this 1a, 3a, 5a, make your little table, negative 2, negative 1, 0, 1, 2, and your y values here would be 4, 1, 0, 1, 4. You take these and multiply by negative 3, and those would be your new y values. Okay, that's a multiply sign. All right, so let me actually backtrack here. I want to start at the right spot, so I'm going to actually erase these yellow points. I'll use red again as my final answer. I'm going right 4, up 8. So right 4, up 8. Okay, and then you can start this pattern. All right, again, this is for quadratics. So down 3 over 1, down 3 over 1. Oops. Okay, and then from that new point, go down 9 over 1, down 9 over 1. And obviously the 15 isn't going to fit, but I'll try to make my graph look a little bit curved here. The arrows should be slightly going to the left and slightly going to the right. Okay, and they shouldn't curl back in like this. That wouldn't be a function. So that is my final graph. And again, I really highly recommend understanding that 1a, 3a, 5a pattern. It's going to make your life a lot easier, especially for quadratics. It can somewhat be used for square roots as well, but quadratics is where you'll typically see it. Okay, so we went through what this does to the y values. Again, it multiplies the y's on the outside. If that number's on the outside, you can make a new table of those parent points, or you can simply get some of the patterns down. So for an absolute value, we can just do the slopes. For a quadratic, we can do 1a, 3a, 5a. Now, the only one I will mention for like x cubed and cube root of x, which aren't on these notes, and even square root, I'd put into that category. Okay, these guys, I would multiply the y's first. All right, and then try shifting the graph. So kind of like what we did for the first graph. So they don't have exactly a special pattern that you can follow. They kind of do, obviously, but I would say make that table and then multiply. Okay, so we're going to save example 3 for class. That's another quadratic. Okay, and we're going to get some more practice on some of these different guys in class. And then I actually want to look at this one because this one obviously is a little strange. This is the last example here, guys. Now, as you guys know, this is a step function. Remember that one starts here, open circle, starts here, open circle, starts here, open circle. Okay, so something like that. That's the parent graph. When you have numbers involved with y's and x's, etc., okay, here's the rules for that. They're kind of special. So this still multiplies the y's by 2. There's going to be a spacing of 2 between steps. Okay, so we're going to do, start here, and then we're going to go up 2, start a new step. So kind of bigger steps here. All right, so that's what that number does. But this other number, you might guess, does something too. So this typically inside would mean you multiply the x's by 3. Okay, so your steps are going to be 3 long. Okay, so because this is 1/3, you're multiplying the x's by 3. That's really what it's doing. So let's actually try graphing this here. And it's a pretty quick ending once you know those 2 rules. So you're still starting at 0, 0. It's not shifted. We're going to go 3 long. Okay, open circle. Skip up 2 steps. 3 long. Open circle. Skip up 2. Okay, this one doesn't fit, but it's okay. We can go this way a little bit. Go down 2. Okay. Just be careful. The typical error people have with these, we'll stop there. Okay, the typical error people have is they do this. They move this, they put this one like right here. Okay, and they'll be like, oh, I went up 2 and went 3. Yeah, but is this a function? Does it pass the vertical line test? No, right? So just be really careful. You should be starting the new step at the end of the old step. Literally, you should be able to draw in a staircase. Okay, so if you can't draw a staircase and you had to go backwards or something, then you probably did it incorrectly. All right, so that's the rules for greatest integer. Like I said, we'll talk about more of those shifting and this one more quadratic practice tomorrow. So again, thanks for watching, and please let me know if you have any questions.